Hi everyone, my name is Alex Peysakhovitch, and I'm going to be talking about joint work with Christian Kroer and Nicolas Usunier that's on implementing fairness constraints in markets using taxes and subsidies. So we're going to be studying, in this paper, we study Fisher markets. And Fisher markets are simple economic situations where we have N buyers with finite budgets. We have M items or sellers, sometimes they call them that. And we think about situations where buyers have utility functions over bundles of items and money, and the items or the sellers are in short supply. So these markets are going to come to a market equilibrium, which is when we have prices for items that get realized and buyers receive and buyers purchase items. And our prices and the allocations, meaning what the buyers end up getting, satisfy two conditions. So they're going to set supply equal to demand. And by that, I mean they're going to say, well, every buyer is going to be buying what they is going to prefer what they get over anything else that they could purchase at the given prices. And the total allocation is going to be feasible given supply. So this is a market equilibrium. So Fisher markets are an interesting thing to study because, we have lots of different markets out in the world, and lots of these markets have kind of specific rules, right? So if you think about like online ad markets, we have these kind of auction systems where advertisers submit willingness to pay for impressions, clicks, etc. And then there's like an auction system that does a bunch of allocations. Or if you think about like decentralized markets where individuals negotiate prices with each other, these things look very different when you think about the kind of rules that are happening in the market. But at the end of the day, both of these things are just different ways to find prices which set demand equal to supply. So the Fisher market model is kind of really interesting because it allows us to abstract away from the special rules that govern markets and focus only on kind of the demand, the supply, the prices, and the allocations. So the main motivating question of our paper is going to be, okay, we've got market equilibria that are balancing supply and demand. And on the other side, we've got this like a very big recent literature on kind of fairness constraints and allocation mechanisms. Some of this actually touching on, things that are related to markets. So for example, recent work thinking about, okay, should we have kind of balances in exposure in online ad markets, for particular advertisers, they should have balanced exposure to certain subgroups of users, right? So we're going to think about, okay, how can we in general have market equilibria that's now begin to satisfy fairness constraints? So the main tool that we're going to focus on for achieving these fairness constraints in market equilibrium is the ability of market designers to use taxes or subsidies, so meaning change the price of a transaction for particular groups of buyers for particular items. We're going to look at the uses of tax and subsidies to try to nudge allocations towards satisfying fairness constraints that we care about. So the paper's got a bunch of theoretical results. I'm going to try to really quickly go over them from like a 30,000-foot view. And, I encourage you to see the paper for details. But basically, let's think about we have X, which is going to be a matrix of allocations of items to buyers. So let's say Xij is the allocation of how much of item J buyer I is getting. And suppose that we have a family of linear constraints that we want this allocation to satisfy. We're actually going to show that there's going to exist a system of taxes and subsidies such that when the market designer uses those taxes and subsidies, we're going to satisfy our constraints in the resulting equilibrium. So again, 30,000-foot view. I encourage you to see the paper. It's for the filling in all the blanks. So the existence thing is kind of one of our big results, but our second theoretical result is thinking about not the static case where there's kind of like just a market and it reaches equilibrium, but thinking about an online case where the market kind of happens, at every time period. So each time period, buyers and sellers show up, and then the market equilibrium is realized, and then it happens again tomorrow, and the day after, and the day after. Right? So this is like, again, think about online ad markets having this kind of temporal aspect. So in the paper, we actually provide an online algorithm for setting taxes and subsidies that's going to converge to the optimal taxes and subsidies for a given set of constraints, like optimal in the sense of the last slide. What is sort of neat about this algorithm is that it's an algorithm with a very low information requirement. So the market designer doesn't actually need to observe anything other than the market outcome. So all you need is you give me the constraints that you want to satisfy, and you tell me what happens at each time period. And you don't need to know a bunch of private information like things like buyer utility functions, buyer budgets, and etc. So those are the kind of like two theoretical results in the paper. And in addition to thinking about kind of the theory of doing these interventions, we spend about half the paper talking about, well, yes, you can do them, but markets are these like very complicated interacting things. And in particular, you can get a lot of second order effects. And so that means that various interventions that one might make in a market may have unintended consequences. So in the paper, we have a bunch of different examples of this, but here I'm just going to talk through one really quickly just to kind of give you a flavor of what we have. Okay, so let's talk about one very simple example that appears in the paper that's sort of, very loosely motivated by some of the great work done by Ali et al. In 2019 in online advertising markets. And we're just going to think about a very simple case where we're going to enforce parity constraints in order to ensure parity of exposure across some groups of individuals, meaning here suppliers, to some, again, we're thinking of an ad market, so the buyers here are going to be advertisers. So we're going to take a very simple case where our buyers are going to have linear utility in items, meaning the utility of item A and item B is just the utility of item A plus the utility of item B plus whatever budget I have left over. And we're going to look at this very simple example where we have 4 buyers. 2 of the buyers are going to be, our special constrained buyers with the valuations given by their rows. 2 of our buyers are going to be normal buyers with the valuations given by their rows. And then in the middle panel, what you see is if you take these valuations, assume everybody has a budget of 1, and compute the market equilibrium, you get this kind of allocation, right? Where item A is split between buyer 1 and buyer 3, and item B is split between buyer 2 and buyer 4. So now, suppose that we're going to go and we're going to add a constraint where it says, okay, all of the constrained buyers must have equal exposure to item A and item B. So what is going to happen? So when we go ahead and do this, what you see is that in this new constrained equilibrium, our constrained buyers end up saying, well, something that is equal exposure is 0 to both. And so remember that because their utility includes their leftover budget, they essentially say, okay, it's way too expensive for me to try and purchase these balanced bundles of items. I'm just going to keep my budget. And that leads the items to just be split between our 2 normal buyers. Meaning, if our original goal of adding the equal exposure constraints was to say, okay, look, there's this, group that is underexposed, and we'd like to make an intervention to increase their exposure, it's actually not guaranteed that requiring parity in exposure is going to help them. It may just reduce overall aggregate exposure. So again, just kind of one example that's in the paper. Lots more in there. Okay, so that's it. And there's a lot more stuff in the paper, experiments with the online algorithm, actual proofs of the results, and studies of other properties of market equilibria. So I encourage you to read it. I hope this was interesting for you. And thank you for listening.